C++ arrays. Now here we are having one integer array having the name n with 10 consecutive locations, and here the subscript or the location number will be ranging from 0 to 9. So we are executing one for loop, and the for loop is extending from 0 to 9. So int I is equal to 0, I less than 10, so I can get up to 9 only, and I plus plus I will be incremented by 1 always. Ni, that is at the ith location of the n array, I plus 100. So the value of I will be at first will be 0. So 0 plus 100, 100 will be assigned. 1 plus 100, then 101 will be assigned. 2 plus 100, then 102 will be assigned. In this way, the values will be assigned accordingly. Set element at location I with I plus 100. So now here we are printing headings, that is the element and value. So if we compile our program, and if I want to show you that how the outputs are coming. So now here you see the element is the respective text. This is a respective text we are having element, and set with 13 we are having this set with 13 characters, and then value, and then endl. So here we are having 13 characters, out of them value is having 5 characters. So here in between we are having 8 characters gap, so that we are having this output in a very columnar way. So for int j is equal to 0, j less than 10, j plus plus. So again the j is ranging from 0 to 9. So cout set with 7, and then we are printing this value j. So here you see we are having this 7 is the width, and then 0 to 9 they are the single digit numbers. So as a result of that we are having 6 blank spaces beforehand, and then numbers are getting printed. And then set 13, again we are denoting, we are having this set with 13 characters, and out of them 3 of them are getting occupied by the 3 digits. So 10 blank spaces beforehand, so they are coming. So set with 13, and nj, we are printing this current value of this n array at the jth location, and endl will bring the next line, printing in the next line. So in this way this particular array is getting defined, array has got initialized, then array content is getting printed. So in this way we have explained this program line by line. I think now your conception is getting clear at this particular stage. C++ bitwise operators. Let us explain this program and also to show you that how the bitwise operation can be done in C++. So here this value of a is equal to 60. In binary it has been expressed in this way. Value of b is equal to 13. So in binary it has been expressed in this way. And c is equal to 0. Okay. Now a and b. So that means I shall be doing the bitwise ANDing. We know that 1 and 1 is 1, and 1 and 0, or 0 and 1, or 0 and 0 will produce output 0. So if you do this bitwise ANDing, I'm getting this 1 1 will survive, and all of the rest bits are getting ANDed with either one of the zeros will be there. So as a result of that, the output will be like this, which is nothing but 12. So if you print the value of c here, so I'll be getting 12 here. So in case of odding, the output will be like this one. The decimal equivalent is 61. So accordingly it will get printed. So 61 is supposed to get printed here. Okay. Now here we are having the respective values, that is a XOR b. So a XOR b means we know that 0 and 1 and 1 and 0, their XOR will be 1. Zeros are 0 and 1s are 1, the XOR will be 0 in that case. So similarly, if we do this XORing, so XOR will be denoted by this particular upper caret symbol. So there is a representation of XOR. Okay. Now, so if you do the XORing between this A and B, so then the output will be obtained as like this one. So you just go on doing the XORing, we will be getting this output like this, and that will be 49. So 49 is supposed to get printed here. So here we are doing this complement. Complement means ones complement. So 0011 1100 will be converted to 1100 and 0011, and which is nothing but minus 61, because here this one will indicate the number is negative and the respective value will be obtained by taking the 2's complement of that. So it is minus 61. So value will be minus 61. So line 4, the value of C is this. So let me execute the code also side by side. So here we are getting this, that is C is equal to minus 61. Okay. Now next one is A. There is a double arrow. This particular double less than symbol will indicate that we are moving this A. All the bits in A will be shifted towards the left hand side. So left shift will take place for 2 bits position. So ultimately we are getting this value, and this value is nothing but 240. And here we are doing this right shift for 2 places, right shift for 2 places. So here is the respective value whatever we are going to obtain. So if we do the left shift for 2 places, then in that case 2 bit positions, then in that case these 2 zeros will disappear. And if we do the right shift for 2 places, 2 bit places, then these 2 zeros will be disappearing, and the free space will be filled up with zeros. So as we did here, so it is nothing but 15. So similarly we are getting this output like this. Now let me execute the same code. Now let us execute the same code in our GNU. So G++, program name is prog16.cpp, minus o a.exe will be the output file name. So if I execute the code now, after compilation, we're getting the same output which we obtained in case of dep C++ output. So in this way, we have explained the execution of this program, and this program is dealing with different types of bitwise operators. C++ relational operators. We are going to execute our code and we shall explain the output line by line. So here we have done the compilation and run. So here we are using dep C++ for the execution of our code. So this is the respective output. So A is equal to 21, B is equal to 10, and C is defined but uninitialized. So A is equal to B is false. So that's why the control will be coming to the else part, and line 1 A is not equal to B. So line 1 A is not equal to B has got printed. Now A less than B, A is equal to 21 and B is equal to 10. So A less than B is false. So the control will be coming to this else part. So line 2, A is not less than B, A is not less than B. So A is not less than B. So the corresponding output has been explained logically. So now if you go for the next part, that means A greater than B, and here it is true because 21 is greater than 10. So line 3 A is greater than B is going to be printed. So line 3 A is greater than B has got printed. So now here we are having A is equal to 5 and B is equal to 20. So now if I go on printing, A is equal to 5 and B is equal to 20. So if A less than equal to B, so A less than equal to B is true. So line 4 A is less than or equal to B. So line 4 A is less than or equal to B. And B is greater than equal to A. Line 5 B is greater than or equal to A. So B is greater than or equal to A. In this way, we are getting this output logically explained. C++ logical operators. Now let us explain this program with the execution. Here value of A is non-zero, that is 5, and B is also non-zero, that is 20, and C is uninitialized. So A and B, here we are doing this particular logical operation. So here is the logical operator AND. So A and B, here we are getting the line 1, the condition is true, because here A is non-zero and B is also non-zero. So now non-zero means both are true. So true and true will be true. So the condition is getting satisfied and the output is obtained. So let me execute the code at first so that we can have the better understanding. So let us execute the code in GNU++. So we are having this compiler G++, and then our program name is this one -o. The output file will be say a.exe. So after compilation, if I execute, I'm getting line 1 condition is true. So really I'm getting this line 1 condition is true. A or B, here both A and B are non-zero, so both are true. So true or true will be output will be true. So line 2 condition is true is getting executed. So now A is equal to 0 and B is equal to 10. So A and B will be returning the value 0 here or false here, because 0 means false and non-zero means true. So false and true output will be false. So condition will be going, the control will be going to the else part. So line 4 condition is not true. So line 4 condition is not true. So the output is coming accordingly. And if you take the negation over it, so if we do the complement of that, then we are getting line 5 condition is true. So line 5 condition is true is coming accordingly. So if we do the compilation and if we do the execution in C++, we are supposed to get the same output. Really, we are going to get the same output as we got in case of GNU C++ program compilation output. So in this way, the program has been explained. C++ assignment operators. Let us explain the execution of this program now. Here we are having this int a is equal to 21, int c which is uninitialized, c is equal to a. So let me execute my code so that we can get the idea that how the outputs are obtaining. So I'm executing my code now. So this is the output screen we are getting. So also I'm putting this notepad side by side to do any rough work. Okay, int a is equal to 21 and c is defined but uninitialized. C is equal to a and the value of c has got printed. So c has got printed as 21. C is plus equal to a, that means c is equal to c plus a. So c is having value 21, a is having value 21. So 21 plus 21, 42 will be the new content for c, and that has got printed here. Now c minus equal to a, so 42 minus 21. So c is equal to c minus a, so 42 minus 21, so 21 will be the new value for c. So 21 is coming for the new value for c. Now c star equal to a, so now c is having the value 21 and a is also having the value 21. So 21 into 21, the multiplication is taking place, and that is 441. So in this way you are getting this 441. So now c slash equal to a, that means c is equal to c by a. So that means 21 squared by 21, so that is 441 by 21 is equal to 21 will be the new value for c, and yes, the value of c has got printed as 21. Now c is equal to 200 and c percentage a, percentage is equal to a, that means c is equal to c percentage a. That means the value of 21, this particular value 200 rather, will be divided by 21, and the remainder whatever is getting obtained, and that will be assigned to c. So the value of c has become 11 in that case after doing this remainder operation. So c, there is a left shift equal to 2. So that means that we are going to shift the value of c towards the left hand side for 2 bits place. So we know that 2 bits place left shift means 2 to the power of 2, that is 4 will be multiplied in the resultant value for c. So 11 into 4, so the output will be 44 in that case. So now again we are doing the right shift for 2 places, and as we are doing the right shift for 2-bit places, so that 44 has to be divided by 2 to the power of 2, and that is 2 to the power of 2 means 4. So again we are getting back this 11. Now C and 2. So 11 means, we know that if you write 11 in byte form, and that is 8, 4, 1, 2 and 1. So it is 11 is nothing but 8 plus 2 plus 1. So that's why I have placed 8. That means 1 I have placed in the position of 8. So 0 I have placed in the position of 4, and in the position of 2 and 1 I have placed 1 and 1. So now if it is getting ended with the value of 2, so that is 0 0 1 0, then I'm going to get, after doing this ending, I shall be getting this 2 as a result, so which is nothing but 2. So that's why after doing this AND operation we are getting this 2, and then we are doing this XORing with 2. So we are doing this XORing, so 2 XOR 2, always it will be 0, because similar bits XOR will produce the output 0 in that case. So if we do the XORing between these two, if we do the XOR, then obviously the output will be 0. So similarly I'm getting this value C is equal to 0, and in the last we are doing this ORing with 2. So with this result, if we do the ORing, then obviously the output will be 2 again. So in this way the output has become 2. So in this way we have explained that how the outputs are coming, and the same outputs will be obtained in case of GNU++ if you go on compiling our program in GNU++. So in this way we have explained our code with the proper tracing, that how the values are getting generated. C++, the hash operators. In this program we are going to define the usage of the operator hash. We know that operator hash causes a replacement text token to be converted to a string surrounded by quotes automatically. So here you see, here we have written this mkstr hello C++. So please note that here this hello C++, this particular string is not enclosed within double quotes. So we have defined one macro here. So hash define mkstr x hash x. So that means this particular x is nothing but hello C++, and it will be enclosed within double quotes, and accordingly the output will be obtained. So now let me execute my code. So I have clicked on compile and run option, and now if I execute my code, I'm getting this hello C++. So thus we have explained the usage of operator hash, which is causing a replacement text token to be converted to a string surrounded by quotes. C++ hash operators. Here we have defined concat a comma b, a hash b. So in this program we are supposed to discuss the usage of the operator double hash, and when this concat appears in the program, its arguments are concatenated and used to replace the respective macro. So here we have used this concat x comma y. So now this x and y will be coming down here, so they will get concatenated, so they will become the variable xy, and here we have initialized this variable xy with the value 100. In the similar way, str and 1, so when they will be coming to str and 1 to a and b, then obviously this str and 1 will get concatenated. So as it is hash defined, so preprocessor will come into the play, which will replace this particular part by xy, and which will replace this particular part as str1. So the respective variable xy content will get printed, and respective variable str1 its content will get printed. So preprocessor will come into the play, which will do this macro substitution, that means replacement of this particular macro called by the respective macro body. So now let me execute my code, and I'm expecting 100 and hello world going to get printed as the output of this program. And according to our planning, yes, we have got this 100 and hello world has got printed here. And this is a very good example of uses of hash operators and macro substitution. C++, the raise function. In this program, we are going to discuss this function raise. You see, like the previous program, here we have defined one signal handler function. And here is a signal function which requires two arguments. The first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. When the signal will be generated, how to handle the function, how to handle the situation, that will be written in the respective function code. So in this way, we have written this signal handler here. We could have given a separate different name according to our wish to this respective function as well. So now here you see, here this value of I is equal to 0 initially, and this while is not falling in an infinite loop. It is just going for I is equal to I plus 1, that is plus I, here we have done. But when this value of I is equal to 3, that means when this value of I is equal to 3, then we are raising sig int. So in this way, when the value of I will be 3, then the signal int will be raised and the corresponding program will halt here. Okay, and each and every time after printing going to sleep once, it will wait for 1 second delay. To have this particular function running, we had to include this respective header file, that is unistd.h. Okay, now let me execute the code at first. So you see, if I execute the code in def C++, the output is coming like this one. So interrupt signal to received. So here this value of this signum is 2 here. The value of this signum is 2 here. So accordingly, it is getting printed. C++ pointers to structures. Let us explain this program. So here we have defined one structure variable. The name of the variable is books, and which is having 4 fields. First 3 fields will be of string type, so that's why we have defined character arrays for them, and the last field is of the type integer, which is containing the book ID. Here we have defined 2 structure variables. One is the book1 and another one is the book2. So now to initialize first 3 fields, we have used strcpy function so that we can copy these values to the respective fields as well. And this is the book ID has got initialized. Similarly, for book2, we have initialized all the 4 fields with the respective values. In the print book function, this is a print book function which is taking one address of the structure variable. So that means it is taking the address of the structure variable book1. So as a result of that, the respective prototype for print book will be struct books pointer, and it is returning nothing as output argument, so its output type will be of void. So it is returning nothing, so the output type will be void, and it is taking structure variable address as input argument. So that's why the input argument data type will be struct books pointer. We know that in case of prototype declaration, this variable name is optional. So instead of writing this struct books pointer book, we could have written only struct books pointer. Okay, now see, that is the function body. Here we have defined the function body. So struct books pointer book is there. Now to access the respective fields, I cannot use the dot, that is a membership operator, because here this book is not a structure variable, but it is a structure pointer variable. To access its respective fields value, I must be using implies, that is minus greater than, implies operator. So book dot title is not applicable here. So book implies title, book implies author. In this way, we could have retrieved all the four fields value. So let me execute the code at first so that we can get the idea that how the outputs are coming accordingly. So we have initialized book 1 and book 2, and also we have printed book 1 and book 2 respective values, and you can find that the values are coming quite perfectly. So here, instead of using book.title, we should be using here book implies title, as book is not a structure variable but it is a structure pointer variable. C++, the namespaces with directives. In this program, we have defined two namespaces. The namespaces, the first one is the first space and the second one is the second space. In the first space, we have defined one function with this body. And in the second space, we have defined the same function with the same prototype, but the body is containing the statement like this one. So now, int main, from the main function, I'm calling this func, func. This particular function has been called. But if we use this namespace first space before this particular main, the function body, then in that case, let us see that what will be the output. As we have written using namespace first space, so this first space, the respective function, that is the func, this function will be called this one, and as a result of that, inside first space, that message will get printed on the screen. So if we change this one, if I make this one as second, if you go for the second space in that case, then we are expecting that this particular function func is supposed to get executed, and inside second space this message is getting printed on the screen, on the console. So in this way, we have got the idea that how this namespace is playing a very vital role in the decisive factor that which function is going to get executed when both the namespaces with the different names are having the same function prototype but with the different body as well. I think now the conception is getting clear to us. C++, the signal function. In this program, at first we shall register the signal sigint and the signal handler function through the signal function. So here is a signal function for us. We have called this signal function, and the first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. That means when that corresponding signal will be generated, then what is the respective activity we are going to do. So that has to be maintained or mentioned in the signal handler function. So here you see, here we are having this main function, and the main function has gone for an infinite loop, and it will go on printing going to sleep, and that is one sleep function we have called, which will make the program halt for 1 second. And in this case, to have this particular function defined in this respective header file, so that's why we have included this one. Okay, now let me execute my code for the better understanding. So now when I shall execute, when I shall click on compile and run option of this dev C++, then we are finding this each 1 second we are going to get going to sleep. This message is getting displayed until I press Ctrl C from my keyboard. So if I press Ctrl C, then I'm coming out, and the last line printed was this one. But as the corresponding output screen has gone off, so that's why we could not see the output properly. C++ class member functions. In this program, we have defined one class known as box. The name of the class is box. Under the public scope, we have defined three member variables: length, breadth, and height of type double, and four member functions. And first member function is get volume, and other member functions are setter functions, that is set length, set breadth, and set height. So here we are having this member function declarations. So outside of this particular class, we are going to define the respective member function bodies. So that's why we should be mentioning that this particular member function is of the box member function. So that's why we have used this one as scope resolution operator. So get volume will just multiply this length, breadth, and height, and the value will be returned. We know that length, breadth, and height, all of them are of the type double, so the return argument after doing the multiplication will remain as double type. In case of set length, the input argument len of type double will be assigned to the member variable length accordingly. So BRE is getting assigned to the member variable breadth accordingly, and this height has got initialized with this input argument, that is HEI. Now in the main function, we have defined two objects under the class box. One is the box 1, another one is the box 2. The double volume variable has got initialized with value 0 after defining. So now we are calling all the three setter functions to set this length, breadth, and height of the object box 1. Similarly, for box 2, we have called the respective all setter functions. Now to calculate the volume from box 1, we are using the member function get volume, and the volume is the output argument, and the volume is getting printed. And then volume is equal to box2 dot get volume, and then here this volume is getting printed, and return 0 is the return value of this main function, as main function was supposed to return one integer. So in this way the program has been written. Now let me execute the program through the option in this IDE dev C++ compile and run. So if you run this code, we are getting this output like this one. So volume of box 1 is equal to 210, and volume of box 2 is equal to 1560 accordingly. So this volume have got calculated through the member function, that is our get volume. Okay, now let me execute the same using GNU++ compiler. So I'm going for this one. So G++ proc62.cpp -o output is A. So a.exe will get produced after doing the compilation successfully, and then we are executing the code by issuing the file name a.exe. So A is there. So volume of box 1 is 210, and volume of box 2 is equal to 1560. So you see the dev C++ output and this GNU C++ compile program output, they are same. In this way, we have explained how this program is getting executed. We have explained the program execution line by line. Operator overloading in C++. Here we have defined one class. Name of the class is box. It is having three setter functions: set length, set breadth, and set height, to initialize these three member variables defined under the private scope, and they are of the type double. We have defined another function here, another member function, and which is nothing but overloading the plus operator. So it is returning a box class object as output argument, and which takes one box class object reference as input argument. So it is defining locally a box class object box. Its length, breadth and height is getting initialized by adding this implies length plus b dot length, this implies breadth plus b dot breadth, and this implies height dot b plus height. Here this is nothing but is known as this pointer, and which is referring to the current object from where this operator plus overloaded function is being called. So it is defining or referring to that object from where this operator plus overloaded function will be called. And in this way it is just adding the current object's length and this input reference object as parameter passed as a parameter, its length, and these two length values are to be added to give the length of this locally defined object box length. So in this way we have initialized them, and at the end we are returning this box object. So that's why its output argument will be of the type box. So now here we have defined three box objects under the class box, and they are box 1, box 2, box 3, and this volume is initialized with 0 of the type double. So here we are initializing using the setter functions the length, breadth and height of box 1, and similarly also for box 2. So now box 1 dot get volume is being assigned to volume, and later this volume is getting printed. Box 2 dot get volume is being assigned to the volume variable, the same variable, and the volume is getting printed here. We know that volume we have defined under the main function of the type double initialized with 0.0. Okay, now box 3 is equal to box 1 plus box 2. So this box 1 plus box 2, they here we are passing two objects with this plus operator. This particular calling, implicit calling of the overloaded function plus, and actually here we are getting the same. So it is calling this overloaded function class, overloaded function plus here. Okay, now see. So box 1 plus box 2 is now getting added, and box 3 is obtained, and then box 3 dot get volume will do the rest for us. Okay, now let me execute the code once for the better understanding. If I execute the code, I'm getting this. So 6 into 7 into 5, so we are getting this one as 210 as the required output. And when you were multiplying 13 into 12 into 10, when you are multiplying 12 into 13 into 10, we are getting the value as 1560. But when you are calculating this box 1 plus box 2, that means this 6 and 12 are getting added to decide the box 3 length. So 18 will be there, 7 plus 13, 20 will be for the box 3 breadth, and 5 plus 10, 15 will be the box 3 height. So now when you are calculating the volume of them, actually we are multiplying 18 into 20 into 15, and we are getting the value as 5400, and thus the volume is getting printed at the end of our program. So this is the required output here. So if we execute the same program using GNU C++, so let me see that what is the output there. So G++, and here the name of the program is proc66.cpp -o. Let us suppose we are producing the output file as a.exe. So compilation is getting done, it has been completed, and A has got executed. I'm getting this required output as obtained. So we are getting the same output in GNU C++ compiled version of the program and this dev C++. Now let me write this particular line in another way. So we are writing this one as box1 dot, we can write in this one as box1 dot operator plus box2. We're getting the same output like this one. So this is actually the explicit calling of the overloaded function operator plus. There is an explicit calling of the overloaded function operator plus. So let me write the same part here. I'm just swapping this box 1 and box 2 object names. So we are getting the same output as we obtained previously. So we can write this one, otherwise we can write box 1 plus box 2, and that is the implicit calling of the overloaded function plus. Program has got compiled and output has been obtained as well. So I think now your conception is cleared. What is operator overloading? Joining and detaching threads. In this program, we shall discuss regarding the thread joining and thread detach. The thread join function is the main function which will be discussing in this particular program. It is actually a subroutine blocks the calling the thread until the specified thread ID thread terminates. When a thread is created, one of its attributes defines whether it is joinable or detached. So as a result of that, we should make that particular thread joinable, then only the thread can join, otherwise the thread cannot be joined. So we can say that only threads that are created as joinable can be joined. If a thread is created as detached, it cannot be joined further. So now in this case, here we are having the same sort of coding which we had in our earlier program. So here the name of the function has got changed. So we have made that one as wait, and it is taking one generic pointer t, and this is a long, and here this tid is getting initialized with this sleep function we have called here. These messages are getting printed, and p thread underscore exit function is being called when null has been passed as the respective status. So when the child threads will be created, then this particular wait function will be called, and at the end the child thread will be releasing its space after getting terminated. So this is our main function. So here we have defined one threads array of size 5, and it is of the type pthread underscore t. So here we are just initializing the thread attributes, and we are making this particular thread as joinable. So here we are creating the child threads using the function pthread underscore create. We discussed this one earlier also, that pthread underscore create requires 4 parameters. So first one is the thread reference, second one is the attribute to be passed, third one is the respective function or the start routine going to be executed when the thread will be initiated, and then the last one is the argument to be passed, and its return value will be assigned to RC, and RC is of the type of integer. And if the RC is true, then it will indicate that the child thread could not get created successfully, so then it will print this message, and exit -1 will indicate abnormal termination of the code. And here we are having this thread attribute destroy, and that is reference of the attr has to be passed. Now here you see we have used this particular function, that is pthread join, and it requires 2 arguments. One is the thread id and another one is the status, and the return value will be assigned to RC. So if the RC is true, then unable to join, the thread could not join with the other thread mentioned as the thread ID. So then exit -1 will indicate abnormal termination of the code. And main completed thread is I. So when the thread will get completed, then it will print the value of I, and exiting with the status this and that. So whatever we are going to print is in front of us, and we shall be getting the respective output accordingly. So when all threads will get completed, all the child threads will get terminated, then that program exiting this code will get executed, and the main thread is getting terminated using the function pthread underscore exit and passing null as the status. So now let me go for the execution. Let me show you the execution of this particular program. So here is the respective output for us. You can easily find that initially the threads are getting created. Okay, so that is a main creating thread 1 and then thread 2 and thread 3 in this way. So this is a line which was supposed to get executed when these lines were got printed. Now slipping in the thread and thread with ID 4 exiting, thread with in threads, thread with ID 3 exiting. So these threads are exiting accordingly, and see when the all threads have got their termination, then only the program exiting this code has got executed, because this is the code which will get executed only after termination of all its created child threads, because we made this particular thread as joinable, and you know that in case of after joining, the thread can get executed only if termination of the thread ID mentioned in the joining pthread underscore join function. So in this way, when completed thread ID 0, then 1, then 2, then 3, then 4, then main program exiting this particular code got executed, and main thread has got its termination ultimately. I think now the conception is clear, because we have explained our program line by line.
C++ dynamic memory allocations for arrays.
In this program, we have defined one variable, that is int row, initialized with the value 2, and another variable int call, initialized with the value 3. So here we have defined one variable p value, which is double pointer. That means it is pointing to a block where address will be there, and at that very address it will be getting the required double data. So now this p value is pointing to a block where this row number of, that means 2 locations are occupied, 2 locations are there, and their starting address will be assigned to p value here. So this row here initialized with 2, so that means this p value will be pointing to a memory block which is having 2 subscripts, 2 locations, location number 0 and location number 1, and at that very location addresses will be there. If you go to the respective address, then double data will be there. Now int I is equal to 0, I less than row, I plus plus. Now for this p value, at the 0th place and at the row -1, that is 1, at the 0th place and at the 1 place, we are just defining one array of the size 3, and that array, that memory blocks starting address will be assigned to at p value 0 and p value 1. So it is actually, p value is actually working as an index which is pointing to some memory blocks where 3 locations are there which will be containing double data. So now at first we are getting the values from the keyboard as user input and initializing locations with user input. So we have got this nested for loop, and then we have printed the respective row and column number so that the user can get the guidance that at which row and at which column they are supposed to put the data, and this value taken from the keyboard as input will be assigned to p value RC. Similarly, we are going to display the current content in p value, and in this way we have displayed the content of the p value. So now let me execute the code for the better understanding. So now here we are running this program in GNU C++ compiler. So here the name of the program is doc74, and here we are having this output file as a.exe. The program is getting compiled, and now I'm executing the code. Intentionally I'm putting this data to indicate that row number 1, column number 1, row number 1, column number 2, row number 1 and column number 3, row number 2, column number 1, row number 2, column number 2 and row number 2, column number 3. So in this way I've given this data in a very systematic way so that you can feel that how the data is getting is just putting into the memory locations according to our planning. So in this way you can see that this p value is pointing to actually one two-dimensional array. So let me execute the same code in dep C++, and here we will be putting the values in the same order whatever we had a plan. So here we are putting the values similarly. And we are getting the same output here. In this way, we have shown you that how this dynamic memory allocation can be done for a double pointer variable.
C++ nested namespaces.
In this nested namespace example, here we have defined the namespace first space. Within this particular namespace first space, we have defined one function func, and this is the respective body. Within this namespace, we have defined another namespace, that is a second space, and the same function prototype. With the same function prototype, func function has been defined with this respective body. So this is our outer namespace, and this is our inner namespace defined under this. So that's why it is called nested namespace. Here before this main function, we are writing using namespace first space colon second space. So from the main, if you call the function func function, then we are expecting that this line is getting printed on the screen. So let us go for the execution for the better understanding. So here you see inside second space, this particular message has got printed because I have mentioned first space colon second space. But if I write only using namespace first space, just erasing this part, then we are expecting that I'm just taking this part away. We are expecting that inside first space, that means this function func should get executed, because here we have mentioned using namespace first space. You see inside the first space that message has got executed. That means this func function has got its execution. In this way we have shown you what is a nested namespace and how this nested namespace can influence whenever you will be calling some function for its execution. Thanks for watching this video.
Multiple inheritance.
In this program, we are having one class. Name of the class is shape, and two member functions set width and set height. Also, we are having two member variables under the protected section, that is width and height. This set width is taking input argument as in case of set height, and they are initializing width and height respectively. There is another class. Name of the class is paint cost, and which is taking area as input argument for the member function get cost, and this area is getting multiplied with 70. Let us suppose that 70 is the cost of doing the painting per unit area. So it is returning the cost of doing the painting of the given area. So that's why its output argument is int. Here you have defined one class known as the rectangle, which is having multiple base classes, and from there we are getting the flavor of multiple inheritance. That means from the multiple base classes we are getting one derived class. So this rectangle is having only one member function, that is get area under the public section, and which will multiply this width and height. And obviously this width and height, they are coming from the class shape, because within the class shape we know that this width and height, they were defined under the protected sections. We know that those member variables, all member functions which will be defined under the protected section will be inherited, and they are inheritable. So that's why from the class rectangle I can easily access this inherited width and height member variables, and to calculate the respective area, and area will be returned with the data type of integer. So now within the main function we have defined one object under the class rectangle. The name of the object is rect. We are having one int area, so area is of the type int. Rect.set width 5, rect.set height 7. So width and height, they are getting initialized with the value 5 and 7, and this set width and set height, they were under the public scope, so they got inherited into the derived class rectangle already. So that's why I could set them using the value 5 and 7. So get area will take this, will calculate this multiplication of this width and height. So as a result of that, the product will be obtained in the variable area. So if we multiply 5 and 7, so 35 will be assigned to this variable area. Now rect.get area, also we are printing this 35 as the output, and now we are passing this area which was initialized here as input argument to get cost. So this 35 will be multiplied with 70 to calculate the respective cost, and the cost will get printed. So rect.get cost, in this way member function get cost has been accessed, and this get cost was defined under the class paint cost, and this set width and set height, they were defined under the respective class shape. So from the shape, set width, set height got inherited from the base class paint cost. This respective get cost member function have got inherited. So in our rectangle object rect, we have called all the respective member functions got inherited from either one of the base classes. So now let me compile and run the code. Let me show you that if I want to calculate the area out of this width and height 5 and 7, the area would get calculated as 35, and if we multiply this 35 with the value 70, then we are getting this $2450 as the cost. So let me execute the same code using our GNU C++. So here the program name is plog64.cpp, and output file name is a.exe same. So after compilation, a.exe will get produced, and if I execute, I'm getting the value 35 and $2450 as we got from the dev C++ program output. Thanks for watching this video.
C++ operator precedence.
So let us explain the output of this program, and here we shall explain line by line what is happening. So here this A, B, C, D, E, these are the variables we defined. A, B, C, D, they are having their initial values as 20, 10, 15 and 5 respectively. E is defined but uninitialized. So A plus B means here 30 into 15 by D. So 30 into 15 by this D means 5. So here we are supposed to get the value as 90. So in the first line, the expression will produce the output as 90. So we have defined this, this E has got initialized with this expression's output, and the value of E is getting printed at the end. Okay, now in the second case, what is happening? You are finding this one as A plus B. So that is 30 into C, that is 30 into 15. So that is 450 by D. So D here is 5. So again we are getting back this 90. So as an output. So in case of the third one, A plus B is 30 and C by D is 15 by 5 is 3. So 30 into 3, so 90 will be the output respectively. But in the last expression, B into C, so B is 10, C is 15, so B into C is 150 by D. So 150 by D, here we are getting this D as equal to 5, so 30, and A is equal to 20, so 20 plus 30, so 50 will be the respective output. Yes, we are getting this 50 as the respective output. In this way, using this operator precedence and using this particular program, how the outputs are getting obtained, we have explained line by line.
Function overloading in C++.
In this program, we have defined 3 member functions with the same name, that is print. And here the class name under which this member function has been defined under the public scope is print data. So class print data is a class name under the public section. We have defined this void print int. So this print is taking integer as input argument. This print function is taking one double data as input argument, and this print function is taking one string as input argument. So all the function names, all these 3 function names are print, but their prototypes are differing considering their input arguments. The first one is taking integer, second one is taking one double, and the third one is taking one string. And here whatever the input arguments are there, they are getting printed accordingly. So in this way they are getting printed accordingly. So now we are defining, we are writing our main function. Under this main function we have defined PD as the object of the print data class. So PD is the object and print data is the respective class which we defined earlier already. Okay, now so this is our print data class and this is the print data class object PD. So pd.print 5. So when you are passing one integer, then the first member function is getting printed, because from this very input argument integer type, it is quite obvious that it will get matched with this the first member function definition, that is void print inti. Next time we are passing this 500.263. So 500.263, so it will be calling the second version of this print overloaded member function. And whenever you are passing hello C++ as input argument, it is quite obvious that we are passing a string. So the third version of this print member function will go on executing. So for the better understanding, it is better to go for the execution output. So we have clicked on the compile and run option, and we are finding that printing int. So the first function has been called, 5 has got printed. Printing float, that means the second print function has been called. and it is printing 500.263, and in the last case it is printing this hello C++, so printing character, so it is printing character, so hello C++ is getting printed accordingly, and this is known as function overloading. In case of function overloading, the same function name will be obtained for multiple number of times, but the function prototype must be differing in their input arguments. In this way, we have explained this program line by line, and we have got the clear idea what is a function overloading. Thanks for watching this video.
C++ function template.
So here we have defined one template. Here this is the max function which takes const reference A and const reference B of type T, and it will compare A and B, and the maximum of them will be returned, and which is quite obvious from the name of the function. So that's why the output argument is of the type T const reference. So now here you see template type name T, so we have defined T in this order. So now here if we pass two integer data to this max as input argument, then in that case the max will find out the maximum of I and j. The max will find out the maximum of I and j, and the value will be returned. So here 39 is greater than 20, so 39 will be returned here. In this case, it is taking two double as input arguments, so 13.5 and 20.7. So 20.7 is maximum than 13.5, so 20.7 will be returned here. Here we are having two string, so one is our hello and another one is our world. So according to the alphabetical order, world is higher than hello, so that's why world will be returned in this case. Here you see, here with this max function, we are passing two integer data, here two double data, and here we are passing two string data. So as a result of that, as we have defined this template, so we need not to define three prototypes of this max function. So for the better understanding, let us execute the code, and we should show you that at first it is returning 39, then it will return 20.7, and then the last call it will return world. So here is the output for us, and from here it is quite obvious that why these outputs have come, because we have explained that one logically line by line.
C++ inheritance.
Let us explain this program. Here we are defining one class known as the base class, and this class is having the name shape. Under the public section, we have defined set width one member function, set height another member function, and two variables under the protected section, under the protected scope. So here we are having int width, int height. This set width and set height, they are taking the respective values as input argument, and those values are getting assigned to the respective member variables, and that is the purpose of this two setter functions, set width and set height. So name of the class is shape, and this is a base class because this particular shape has got inherited in the class rectangle under the public scope. So shape is the base class, rectangle is the derived class, and this rectangle is inheriting properties from shape, and here we have defined this public scope here. So as a result of that, all the public members of this shape will be coming to the public section of this rectangle, and all the protected member variables will be coming to the protected section of this rectangle class. So here we have defined one extra member function under the scope under the section public. So return, which is returning the product of this width and height as output argument. So that's why int is the product data type. So now in the main function we have defined one object under the class rectangle. The name of the object is rect. So we are calling this setter functions, as these setter functions got inherited in the public section. So object name dot operator using we can access them as well. 5 has been passed as input argument to this set width, and this 5 will be assigned to w, and that will be assigned to the member variable, that is our width in the class. So in this way the set height is taking this 7 as input argument. So this 7 is getting assigned to age, and then it is getting assigned to the height member variable. So now after getting them, we are calling this rect dot get area. We can find that this get area is also under the scope public. So as a result of that, it is accessible from the outside of the class through object name dot operator. So in this way the total area is getting printed by multiplying this width and height. So for the better understanding, let us execute our program. So that's why we have clicked on compile and run option. And we know that if we keep the value 5 and 7, then the respective area after multiplication will be obtained as 35. Let me execute the same using our GNU C++ environment. Okay, so here we are having this particular options. So now here the program name is proc63. So going for G++ proc63 .cpp -o a.exe will be the output file name. I'm going for the compilation. Compilation has got completed successfully. Now I'm executing. I'm getting the same output as I got in case of deb C++ execution, that is 35. In this way, this program we have explained line by line, and also we have shown you the output after running it in the deb C++ IDE and also running it using GNU C++ compiler.
Function like macros.
So here we have defined one macro using this hash define, and here mean a comma b will have this particular respective body. That means if a is less than b, then it will return a, otherwise it will return b. So now this is the respective body here we are having. So prior compilation, when the preprocessor will come into the play, it will replace this occurrence of mean in our code somewhere with the respective body as this one. So that is known as a macro here. So each and every occurrence of this mean I comma j or any other arguments whatever we will be using in our code will be replaced by the respective body by the preprocessor prior compilation of this code. So now let me execute this program. So as we have put the value 100 for I and 30 for j, so obviously the j will be returned and it will print the minimum value as 30. So in this way the program can be explained, and this is known as macro substitution.
C++ function call by pointer.
Now in this program we are doing something little bit different from the previous one. So here we have defined the variables a and b with the values 100 and 200 as usual, but printed their respective values. So now instead of passing the values in a and b, so here in case of we are passing this ampersand a and ampersand b, that means the address reserved for the variable a and address of the memory location reserved for the variable b as input arguments. We know that addresses don't have any data type. Its content will have the data type. So that's why to get the content of an address, we use the operator pointer. So int will be the data type of the value residing at that very particular address pointed by this variable x. So that's why ampersand a, this thing will be received with this particular format, that is int pointer x. The b address will be kept in y, so content of the address will be of the type integer. So address of A will be content in X and content of the address will be of the type integer. So in this way the things are taking shape. So here we are printing the values of A and B. Now we have passed the addresses of A and B as input argument to the swap function. So these addresses are getting assigned onto this X and Y. So if you want to print the respective values in those addresses, then obviously you are going to get 100 and 200 respectively. Using the third variable, we have swapped the values of this pointed x and pointed y. So now after swapping, we are printing the respective values of pointed x and pointed y. So we are expecting that the value would get swapped in the meantime. So it will get printed not 100, 200, but 200 and 100 in this order. So before swap the value of A is 100, before swap the value of B is 200. Within swap function, before swap operation, the value of pointed x is 100, pointed y is 200, and in this way we are printing. And now within the swap function, after swap operation, the value of pointed x is 200 and value of pointed y is 100. So now when we are returning back, then when we are printing the value of A and B after swap, we are finding that the values have got swapped accordingly, because this x and y, they are holding the addresses of the variables A and B, and the updates have been made against those content of those memory locations. So as a result of that, when the control will be coming back to the main function, the variable A will be having the updated value 200 and variable B will be having the updated swap value of 100. In this way, the values have got swapped. So we have explained this program line by line with the output or screen, keeping that one side by side. I think now the concept is now getting clear to you.
Define C++ objects.
Let us discuss on this very program. Here we have defined one class. The name of the class is box. Under the public scope, we have defined three variables of double type: length, breadth and height of the respective box. In the main function, we have defined two objects under the class box. So these objects are box1 and box2. Also we defined one volume variable under the data type double, initialized with value 0.0. So the first object box1, the respective attributes, that means the member variables length, breadth and height, they have got initialized with the respective values. Similarly, we did the same for box2 object also. So now we know that to calculate the volume of a box, we need to multiply height, length and breadth. So we are doing the same to calculate the volume, and then the volume is getting printed, and we did the same for box2 also, and the volume got printed accordingly. So at first we are going to print, they are going to multiply this 5 into 6 into 7, so the respective value will get printed accordingly. So now let us go for the execution of the code. So we are going for the compile and run option. So for box1, the value is 210, and it is quite obvious because 5 into 6 into 7 is equal to 30 into 7, that is 210. And in this case 10 into 12, that is 120, into 13, that is 1560. So in this way the values have got calculated. So this program depicts that this particular class box containing three variables, member variables under this class defined under the public scope. And these member variables have got initialized when we defined objects, two objects, box 1 and box 2, under the class box. And then after initializing all these member variables, we calculated the volume here as these variables were under the public scope. So they could have been accessed using object named dot membership operator, and in this way the volume got printed for both box 1 and box 2. So now let us execute the same program in GNU++. So here is the output for us. So G++ will be the respective compiler name. So here it is proc61.cpp minus o a.exe will be the output file name. So now let me execute the code after compilation. So compilation has got completed. I'm just executing a.exe and we are getting the same output as we got in case of dev C++ program compilation output. So in this way, this concept has become clear that how the member variables of a certain class can be initialized through the objects and using the dot membership operator.
C++ function call by reference.
Let us explain this program. So here this value of a and b, two variables, are 100 and 200 respectively. We have printed their values. So now in the swap function we are passing this a and b. Look at the prototype. So void swap int ampersand x int ampersand y. We know that in the prototype declaration these variable names are optional. We may also omit them. We could have written this one as int ampersand comma int ampersand also. So whenever you are writing this particular thing, that means we are calling by reference. The function is calling by reference. Call by reference means a same variable which will be occupying one-time memory space allocation will have different names from the different scope of the program. From the main function, the memory locations will be known as a and b, and from the swap function the same memory block will be referred to as x and y, and that is actual concept of call by reference. So now when you are passing this a and b as swap a and b, swap is a function, a and b are two arguments we are passing, and then we are finding this swap receiving this a and b into x and y with the syntax int ampersand x int ampersand y with these references. So temp is a local variable. So before swapping we are printing the values of x and y. Through this temp, using the third variable, we have swapped the values of x and y. After swapping we are printing the values of x and y and we are returning the control. After returning the control, we want to see that whether the values of x and y, which was referring actually the variables a and b, whether these values of a and b variables have got swapped or not. So I think the conception will be cleared if you go for the execution output. So in the execution output, you can easily find that we are printing the values of a and b as 100 and 200 before calling the swap function. Within the swap function, x and y, they have got the respective values of a and b, that is 100 and 200 respectively. After doing the swap operation using the third variable, the values of x and y have got changed, have got swapped within the swap function. After returning back to the main function, when the control will come back to the main function, if I want to print the values of a and b again, I'm getting the values of a and b swapped. So this is a good example of call by reference. So I think now the conception is cleared because we have explained line by line and along with the execution output. Thanks for watching this video.
C++ function call by value.
Now let us explain this program. So here two variables a and b initialize with 100 and 200 respectively. Before calling the swap function, we are printing the current values of A and B. So you are expecting that A will be printed as 100 and B will be printed as 200. In the swap function, A and B, they have been passed. So this A and B will be getting assigned onto variable X and Y respectively. So before doing any swapping operation, we are just printing the values of X and Y variables. So we are expecting that X and Y will be printed as 100 and 200 respectively. Now using the third variable, we have done the swapping. Now after swapping, we are printing the values of X and Y. So we are expecting that X and Y, they are going to get printed as 200 and 100 after getting swapped. Okay, now see. So here is the respective output scheme. So 100 and 200 is getting printed. Before doing the swap operation within the swap function, the values of X and Y will be 100 and 200 respectively. So within the swap function, after swap operation, the values of X and Y will be 200 and 100. Now you see, after swap, the value of A and B after returning back, because here we are having the return statement, so control will be transferred to the next line of the swap function calling statement. So here we are printing this value of A and B, and here we are finding that it was true that X and Y, they have got swapped, that the values of A and B, they are not swapped, because A and B, they are the local variables within the main function, and X and Y, its scope is confined within the swap function only. So A and B, they are local within the main function, and X and Y, they are the variables having got the scope confined within this swap function. So they will have their respective different memory space allocations. So what about the swapping we did will be in the memory locations reserved for the variables named as X and Y. So when we are coming back to the main function, after returning back, when you are supposed to print the values of A and B, it is getting printed from their reserved locations which are not getting updated, which had not got updated. So again, the value of A and B, they are being printed as 100 and 200 as we have mentioned here. So this is known as call by value. That means the values of the variables A and B, they have got passed to the variables X and Y respectively. I think now the program, this particular logic of this program is now clear to us. Thanks for watching this video.
C++ accessing structure members.
In this program, we have defined one structure. The name of the structure is books, and it is having 4 fields which are defined under this books structure. So struct books, and then we are having this character title one array consisting of 50 locations. Similarly for author and subject, subject is having 100 locations against this character array, and one int integer variable, that is book ID. So we are having 4 fields against this particular structured books. So now within the main function, we have defined 2 structure variables. One is the book1 and another one is the book2. So now each and every field of book1, they have got initialized as they are of the type string. So as it is a character array, so we could have used this strcpy, that is string copy, to keep this particular name as a book title, keep this particular name as the author of the book, and this is the subject title. And in this way also we have defined, or we have initialized this book ID with this particular integer value, as book ID was of type integer. So similarly we have used the same strcpy to initialize first 3 fields of this book2 structure variable, and the book2 book ID has been initialized with some integer data. So now here we have print the info against the book1. So that is the way to print it. It is very simple. That is a structure variable name dot title. Here dot is denoting the membership operator. So again we are having this structure variable name dot author, structure variable name book1 dot subject, structure variable name book1 dot book id. In this way we have printed all the four fields value, and similarly also for the structure variable book2. So now let us execute our code and let us see that how these values have got initialized into the fields and how the values have got printed. So here you see all these four values have got initialized, have got put in the respective fields, and also these values have got put in the respective fields and they have got printed accordingly. I think now this conception against this particular structure is now clear to us.
C++ class template.
In this program, we have defined this T as a generic type name. We have defined one class named as stack, and which is having the private member, that is vector elements, and what kind of data we are keeping in this particular elements will be of generic type. So now under the public section we have defined function number 1, that is push, function number 2, that is pop, and function number 3, that is empty. So in this way we have defined this respective class, and in the outside of this class we have defined all the member functions with the respective body. We know that this is colon colon, which is denoting the scope resolution operator, and here we are having this void stack T. As I told you that T is the generic type here, and under this particular stack class we are having this push method, the member function, and this is the respective body here. So ELEMS is nothing but a vector object, and pushback is the respective member function which is already defined under this vector object. So similarly we have defined this pop function, also we have defined this stop function, and which will check whether this vector object ELEMS elements is empty or not. If it is empty, then it will throw one exception, that is out of range exception. So now in the main function we have defined one object under this particular class stack, and here we are doing this data type binding, that is int type, and stack string stack. So here we are defining two objects. We are defining two objects under the class stack, one with the data type int, another with the data type string. So now here we are pushing this int stack, here we are pushing this value 7, and then we are just printing the topmost element of that, and in the string stack we are pushing the value, that is string value, that is the hello, and also we are printing the topmost elements content. Now we are popping out the first element, and that will be popped out, and the second time we are calling this particular pop. As we have found that we have pushed only one element in the string stack, so the first pop will work, but the second pop will produce one exception, and that exception will be handled, and in this case this is the exception const reference ex, and here ex dot what. So this is the respective method which is already defined under the exception, and here you see we can find this one, that when we are popping and we are throwing one exception whenever we are finding that elements dot empty is returning true. So now let me execute my code for the better understanding. So if I do the compilation and execution of the program, then we are finding this one in this way. So the first two push operations will be done perfectly okay. So 7 and hello, so 7 has been popped, so we have pushed the value 7 at first, and then we just print the topmost element, and that's why we got this particular value 7 here, and then we push the value hello here on this string stack, and then we have print the topmost element using the function member function, that is top. So that's why hello got printed. But when we are trying to pop the first element from the string stack, so the hello will be popped out, so that will be no exception. But whenever I shall go for the second time pop method call from the string stack corresponding object, then obviously that will produce one exception, and this exception has been handled here. So in this way, we have explained this program line by line, and this program depicts that how this template can be used as a generic data type for the class also.
C++ calling a function.
Now let us explain this program. So int a is equal to 100 and b is equal to 200. Rate is another variable defined. So in the max function, we have passed the values of a and b. So this a and b, they are supposed to get assigned to num1 and num2. So now in the parameter num1 and num2, they will get initialized with the current values of a and b. That means they are 100 and 200. So now we are checking the value of the comparison of between this num1 greater than num2. We know that 100 is greater than 200. This condition is false. So the control will be coming to the else part, and result will be equal to num2, that is 200. Otherwise, the result will be equal to num1. So the result will be assigned with the current value of num1. So here this particular condition is false. So control will be coming to the else part. So result will get initialized with the current value in the variable num2, and the value of result will be returned. The return value of the result will be assigned to the rate variable, and ultimately the value of the rate variable will be getting printed. So you are expecting that out of 100 and 200, 200 will be the maximum value, and it has got printed accordingly. So now let us go for the tracing of this program, which will help us to know that how the parameters are getting passed. So to enable the tracing mode, we shall have to go to tools, compiler option, and then settings, and then linker. Then the second option, that is generate debugging information, it has to be made yes. If you load this dev C++ on your system, by default all these options will be initialized with no initially. So for this one, you should have to make that one yes and click on OK. So we came from compiler option, then settings, and then linker, and then the second option here. So I've made that one yes. Now I'm putting one breakline here. So this is a breakline from where the program execution will be initiated. I'm coming to the debug mode, and here I'm going for add watch. I want to watch variable A, variable B, variable RET. Also we can do in this way, we can select this num1 and go for this one, and in this way also you can add watch. Okay, so we have taken this a, b, rate, num1 and num2. So all the variables whatever we were having in this main and this max function, they have got listed in the add watch. So now I shall be going for the debug mode. I shall compile my code once. Then I shall go to the debug mode and I shall click on debug. You see my tracing bar has come up to this line. So A and B, they have got initialized with 100 and 200, and rate is uninitialized with the value 0. So now I'm going for this into function. So this A and B will be assigned to num1 and num2. So num1 and num2, they have got the values 100 and 200. So now you see num1 is greater than num2, 100 is greater than 200 is false. So result is going to get initialized. So here let me add another one, that is a result. So here you see result is still with the value 0 because this line is supposed to get executed but not executed yet. So whenever I'm just crossing this line after this execution, the control has come to this statement that is return result, and result has got value 200 already. So this value of result which will be returned will be assigned to the rate variable. So let me check that one. Rate is still with the value 0. So we're going for this one. So now you see rate has got the value 200, and this is the line which is getting printed. So this is a line which is getting printed. You can also see that one in the output. We can also see that one in the output. So this line has got printed. Now the contour will be coming to the next line. So that is a, so after this max value, the value has got printed and return 0. So now we are going for this continue. So the program has got its execution accordingly. So in this way the program has got its execution, and from the tracing it is quite obvious that how we have got the values and how these parameters a and b here, from here they have got assigned to num1 and num2. I think through this tracing, the execution, how this execution has taken place, it is now clear to you.
Default values for parameters.
At first we are considering the function sum. So int is the return type argument for sum function, and int a is the first input argument, and another one is your int b. But this int b is having some default value, so that is equal to 20. So this b is having a default value. This parameter is having a default value of 20. So int result is a local variable within the sum function. Result is equal to a plus b return result. So now from the main function, this particular sum function will be called. So a is equal to 100, b is equal to 200, int result. So whenever we are passing this 100 and 200 through a and b to the sum function, so sum function will do the sum and it will perform the addition of 30 as result, and that will be assigned to result and that will be returned. So the return argument will be dumped here onto the variable result. So when this result is going to get printed, so we are expecting that it will just print 300 as the output, because we know that 100 plus 200, 300 will be the return type argument, and that will be assigned to the respective variable result here. Okay, now see. In this case, we are passing only one argument. Other argument we are not passing. So here we are passing only 100 through a, and other argument we are not passing. So the default value, which is 20, will be now coming into the action. So now this 100 plus 20, 120 will be the sum that will be dumped onto the variable result, and the 120 will be returned, and that will be coming to the variable result, and result is going to get printed. So in the first sum, the sum will be 300. In the second case, when we are calling the sum with one parameter, with one argument, that is a, with the value 100, so the second parameter, the second argument will be taking the default value 20. So the total value will become 120 in this way. So thus we are getting this proper explanation why these outputs are 300 and 120 when you are calling the function with two arguments and one argument respectively.